Hello! In this video, we are going to prove the following theorem. Let A and B be sets. If A is countable and there's a bijection from A to B, then B is also countable. Now, before we get into the proof, let's get some context. To start, what does it mean for a set to be countable? Well, given any set A, we say that A is countable if A is either finite or denumerable. And for A to be denumerable means that there is a bijection from the positive integers to A. Now, in proving this theorem, we're going to rely on a fact regarding finite sets. And that is, given any two sets A and B, if A is finite and there is a bijection from A to B, then B is also finite. Okay, now let's get into proving this theorem. To start out our proof, let's give ourselves two sets A and B, where A is countable and there's a bijection from A to B. And our whole goal is to show that B is also countable. And to do that, we're going to divide this up into two cases, right? Because A is countable, we know that either A is finite or A is denumerable. And what we're going to do is we're going to prove in either case, B is countable. So let's start with case one, where A is finite. Now notice, we have that A is finite, and we know that there's a bijection from A to B. So we can use this fact that we know about finite sets. Well, since A is finite and there's a bijection from A to B, this fact tells us that B is finite. And what does it mean for B to be countable? It means that B is either finite or denumerable. So since B is finite, B is countable. And that's exactly what we wanted to prove. So this completes case one. Now let's move on to case two, where A is denumerable. What does it mean for A to be denumerable? It means that there's a bijection from the positive integers to A. Now notice, there's a bijection from the positive integers to A, and there's a bijection from A to B. It turns out, for any three sets, A, B, and C, if there's a bijection from A to B and there's a bijection from B to C, then there's a bijection from A to C, right? So this property is transitive. So these two facts tell us that there's a bijection from the positive integers to B. And this is exactly what it means for B to be denumerable. What does it mean for B to be countable? It means that B is either finite or denumerable. Well, since B is denumerable, we have that B is countable. And so, in either case, we have that B is countable. And that's exactly what we wanted to prove. So this completes the proof. And so, yeah, that's pretty much it for this video.